Congratulations, you have made it to the end of Knowledge Review number 7. Or have you? Here we are, back again with a part 2 where we're going to focus on something that's going to require a lot of logical thinking. We've done a lot of object-oriented programming stuff throughout this entire DAG application. Now it's time to shift our focus in the Knowledge Review to something that's going to require logic. That's right. Now, at this point, you should have a fully functional DAG application. That DAG application should consist of a DAG engine, as well as a command line interface. Now, if you ran into any difficulty along the way of programming this application, please make sure to check out the videos that we have provided showing you our solution for how this whole thing can be put together. Of course, that is only one of many different solutions, and we tried to make sure that our solution encompassed most everything that you've learned throughout Volume 1 and Volume 2 of this course. Now, if you came up with your own solution, that's awesome. And I'm pretty sure that your solution is going to be slightly different than what we provided. So the cool thing about that is you can see two different approaches for solving the one problem. Now, let's go ahead and focus on part 2. What we're going to do in part 2 is challenge you with replacing the rendering engine. Logan, let's go ahead and bring up the application that they've created. We've already got one running. And here we are at our command line interface. Let's go ahead and type ls real quick. Now, this is the way that our rendering engine works at the moment. Basically, it's just taken and indenting with a bunch of hyphens all of our different nodes, showing you who's parented to whom, right, Logan?
Right. Each of the nodes has a series of hyphens, which represents how deep each individual node is in the hierarchy.
Exactly. So in this case right here, I can see that the only thing that we have up at the root level of the scene is group. And then up underneath group, parented to it, we have spotlight, then parented to spotlight, we have sphere, and parented to sphere, we have light, so on and so forth. So we can see quickly that sphere has two children. It has light, and it has light too. But this is not a very attractive output. What we'd like to do is get something that looks a bit more sophisticated, but we are keeping ourselves stuck or confined to the Windows console. So, what can we do inside this console where we don't have a graphical world to work with? Well, let's go ahead and pull this up. Here we are with a regular command window, and inside this command window there is a there is a command that we can use, which is called tree, to generate sort of a graphical representation of all of your folders in a directory structure, right, Logan?
Right.
Let's go ahead and show them what it looks like.
If I run tree from within this folder, what we get is a recursive listing of all contained folders inside of that folder.
Take a look at this. Isn't this so much nicer looking? And let's think about these folders. Basically, it's the same thing as our DAG back here. I mean, we have a parent folder, and then we have a folder within that folder, or we could say a child folder, which has a child folder, which has two children folders, and then one of these child folders has all sorts of children, okay? I mean, wouldn't it be nice to employ this same kind of output to our application? It would definitely look a lot cooler. Don't you agree?
And a lot cleaner. In this method, we use both horizontal and vertical lines to basically trace the connections between parent and children nodes.
Exactly. Now, this is an advanced knowledge review section. And I say that for the simple fact that this isn't a matter of creating a bunch of objects and instantiating them and things like that. It's not like that. This section here is a focus on logic. So this is going to really task your logical thinking skills. If you find yourself stuck, try drawing it out on paper. That's very, very important in this particular case. If you sit down and just coding, you're going to find yourself dealing with a greater nightmare than just sitting down and trying to code out the original specs that we presented for the DAG application. Don't just sit down and start coding. Try to draw it out on paper, because it's going to be very tricky how you're going to come up with these characters as things become more and more indented. Okay? Now, fear not, if you have trouble getting this, in the next video we will walk you step by step through the creation of this more advanced rendering engine. Okay? So there's no reason to panic if you do not have any clue how to put this together. But keep in mind, in the next video I am not going to whiteboard it out. We are simply going to code it and explain it. What I want for you to do, if you have no idea what was going on, is to take the code we've given you and trace it out on paper yourself. Use that as a technique for learning how to start drawing things out if you have no idea what it is you want to design. So basically, we're going to give you the answer and have you back up and try drawing out what's taking place in the answer on a piece of paper. So kind of some reverse engineering there, if you will. Now, That's the goal. Logan, is there anything you want to add to this?
Only one thing to point out is that it still needs to work in the same way as the old LS, and that is you can list from any given node. If list is given with no parameters, it lists the entire scene, but if it's given a node, it will list from that node and on.
Exactly.
We need to maintain that behavior in the tree version.
Okay, and let me think. Is there anything else? I don't think so. That's pretty much it. That's it. Yeah. Okay, so we're going to go ahead and wrap up this little challenge here, and we'll see you in the next video where we'll put it all together. Thanks a lot.